Welcome, everyone. I'm Tracy Fitzpatrick, and I'll be your moderator today. Thank you so much for joining us here at Netcom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. We are very excited to host today's event, Data-Driven Decision Making, How to Build an AI-Enabled Organization. Presenting today's topic is Imran Ahmad. Imran is a seasoned technologist and AWS and Google Cloud authorized instructor, specializing in cloud computing, AI, and algorithm design. Known for simplifying complex concepts, he delivers hands-on, impactful training that empowers professionals to build secure, scalable cloud solutions. His writing and teaching bridge theory with real-world application, enhancing skills in cloud architecture, AI, ML, and DevOps. With a multi-cloud approach and a passion for innovation, Imran mentors learners through certifications and practical adoption strategies, making tech education clear, relevant, and career-focused. Please bear in mind that this is an overview of a very robust topic. We offer a collection of technical and business courses that can be tailored to your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. Today's session is also being recorded, so you'll get free access to the recording in the next 24 hours via email. Netcom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adapting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We do have 9 practice areas in which we specialize. They encompass people, process, and technology training. Today's presentation is from the Cloud Practice Area. Netcom Learning offers a comprehensive training portfolio of courses for the topic being covered today. Our upcoming classes include various trainings on the given courses. You can also access a variety of marketing assets, such as the free training and blogs, by clicking on the available event handout. These offerings can be found with a simple search on our website at netcomlearning.com. Today's session is designed to equip business leaders and professionals with the tools and insights needed to thrive in a data-first world. As key decision makers, you'll dive into how AI-powered analytics can transform raw data into strategic action-driving innovation, streamlining operations, and unlocking new growth opportunities. I would like to give you a quick overview of the logistics before we get started. To begin with, you do have the option to view in full screen by clicking on the full screen button on the right side of the GoToWebinar viewer. Simply hit the escape key to exit the full screen. Everyone has been muted except for our presenters. Feel free to submit any questions you have for the presenters here in the questions pane, and we will address them at the end of the session. And to get the best out of today's events, we've included the slides, courses we talk about, and marketing assets in the handouts section of your GoToWebinar viewer. You may refer to them at any time to get a better understanding of today's topic. And we do realize that some of you may have to leave early and want to let you know that as you do leave the session today, you will be presented with a short survey. We would like to request for you to take a quick moment to participate in that survey. Your feedback really helps us understand your learning experience and improve our future sessions for you. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. And now I'd like to pass this over to our trainer to present today's topic. Hey, Imran, thank you so much for joining us today.
Okay, welcome everyone. Welcome to this interesting topic that we have chosen for today's webinar. And the topic that we have chosen is quite relevant to what's happening in the decision-making process around us. And that is, we are trying to find the role of AI in decision making. Does it work? Does it not work? At which at what time it should be enabled? What are the risks and benefits associated with that? So we are talking about data-driven decision making. So when we are making decisions, important decisions, can we rely on the data that we have? And what are the, first of all, how to do that? What are the benefits coming out of it? Are there any case studies? Are there organizations, any organizations that they have tried, and what is the benefit and risk associated with that as well? We'll talk about it. So now AI is a big word that is used these days. We'll try to demystify it. That what do we mean by AI in the context of decision making and at the organizational level. So we are talking about two things here. These decisions that we are talking about, they are critical decisions. It's not about identifying between cats and dogs, or it's not about that. We are talking about critical decision making. And the second point we are trying to make here is that we are talking about large scale. Um, uh, the organizations that operate on large scales, so let's look into that. Let me first start with introducing myself. My name is Imran Ahmed. I'm Dr. Imran, and I'm based in Ottawa. And I'm very much related to this topic as well for the last almost 11, 12 years. My full-time job is with Canadian federal government. I'm a full-time employee. I'm a data scientist there. And what we do there is that if someone applies for immigration, someone applies for student visa, someone applies for work visa, there are 11 different lines of business. And uh, so there are 11 different lines of business, LOBs. And based on that, what we do is that we try to use the power of AI to accept or reject the decision making. So in many ways, this is about the criteria that I was talking about here, that we are talking about the decisions that we take. They are critical decisions. They can affect each data point that is a human life, a person who wants to come to Canada, and the decisions need to be made in a way that are fair. And if so this is my full-time job and quite relevant to to the topic that I'm talking about today. I did PhD from Carleton University back in 2009 when machine learning AI is one of the topics, not the topic. I created an algorithm Astra-org that is still used. And I wrote this book, 50 Algorithms Every Programmer Should Know. That was the bestseller last year. And these days, so it was basically the second part of 40 algorithms every programmer should know that I wrote during COVID years. These days, I'm writing a book. I've just started writing 30 AI agents that every AI engineer should know. So that will be published later this year. So I teach for different companies. I'm an authorized instructor for Google, and I also teach for AWS as well. Now, if I did masters from the same university. And what else? I think that's enough about me. My publications and everything are right here. Let's go back to the topic and let's see that based on my experience, why do I think that it's important to first of all rely on data for decision making and use that to optimize the decision making process. So we will start with looking at what do we mean by data first strategy. Now, data first strategy means that your data is not the afterthought. It's critical. It means that when you uh, when you create a solution, so this is something that you bake into your infrastructure, into your methods, into your platform, into the solutions that you provide at every stage of your final solution. So you rely on the data. It's not that the solution is already there, then you read somewhere that okay, let's try to now rely on data for decision making. So it should be baked in right from the start. So we'll also talk about basically how we can achieve. So the data tells a story. So, but that story is best told when we are aware of all the data that is available to us across the organization. So it means that if you have those silo systems, then you are only looking at the partition of the data. You are not sure that across the organization, what type of data is available. Then um, designing and implementing cloud native data platform, because cloud is a great tool for data processing, data engineering, for AI. Because of what's the reason it's great? Because the reason is it is elastic. Elastic means that it can expand and shrink. It can provision more resources, or it can take back, or the resources can be unprovisioned based on need. And now this makes something that is unbelievable. It makes infrastructure that is performant, performs, and it's cost effective as well. To sort of different requirements we are able to meet, because we are always looking for elastic infrastructures to control the cost and also making sure that our systems are performant. And that is why cloud native platform, they are a natural fit for this data first strategy. Then from now many you will the numbers from last year is that more than 80% of the AI solutions, they were not deployed. What it means is that they were created, they were used in the dev environment, people experimented with that. But if you look into whether they were used in actual problem solving or not, so the number is as low as 20%. It means that when you are creating these solutions, so what we're talking about here is that less than 20%, this small pie is actually useful, is actually used. If these are all the AI solutions created, so only 20% were actually operationalized. They were actually used for problem solving. We'll also talk about that. What are the reasons for it? Why? Um, uh, of course, in from the dev environment, not each and every. So there are sometimes we don't have the right expectations. Sometimes our requirements, they are not well defined. Sometimes the functional requirements are lacking, or the non-functional requirements are lacking, or we have the wrong understanding of the potential and the risks that are associated with AI decision making. And sometimes we just learn as we go, and the result is that the final product that we have, it works in the dev environment, but it's not fit to, perhaps we need another iteration to go towards the final solution. Now we'll also look into how to choose now there are so many tools available. We'll see that what are the right tools, and governance is important. And changing the whole culture towards AI, it takes effort. As we go towards more constant learning, you are always learning. You are always curious. You are always looking for solutions. You have so now that mindset is needed if you want to create a data first strategy. So first of all, let's talk about what does it mean. Data first. What does this mean? Now, the core definition is that if we are willing to embed data into every strategic decisions and process. So what do we mean by these strategic decisions? What is meant by this? I'll give you an example that uh, so what is the alternative? Alternative is go by intuition. Human intuition, it may or may not be accurate. And if someone wants you to defend it, what is the reason? What is the logic behind it? You will say, okay, it's just my gut feeling. I think because of my experience, but you cannot basically prove that that is right. I'll give you an actual example here. So there are so many examples. Just one of the examples that I came across recently. We were looking at um, the people who visit Canada, and uh, in the meeting room, there was a consensus that there are more people who visit Canada in summer as related to the people who visit in winter. So we are doing some capacity planning, based on that we need to do capacity planning, and the consensus was yes, it makes sense. It's such a beautiful place in the summer. The weather is nice, the width and the width of Canada, the nature, the national parks that are there, Rockies, all of this, people visit from all over the world. And in winters, it's so cold, it's so, and the people who visit Canada, they are a fraction of what they visit in summer, right? So one of the data scientists, he said that's not true. This is no more true. So there are different type of people who visit Canada in the winter, and they are students because your session starts in fall. They arrive in fall, and there's another session that starts in winter. And starts on 5th January usually. Now, as Canada is providing more incentive for international students to come to Canada. Now, the people who are coming as tourists, they are at par with the people who come as the students. We still need visa officers. We still need capacity to process them at the border. So it's your intuition is wrong. So, and he showed the chart, and everyone was just, and no one can disagree with that person because the data is right there. It's exact numbers are there. How you can disagree with that. But based on intuition, intuition says that okay, yeah, of course there will be more people visiting Canada in summer. But as Canada is providing more and more incentive for the students to come to there are different reasons. I'm not into policy, but data speaks for itself, and this is basically where we say that data first means that you keep your beliefs, your political affiliation, or your beliefs aside. Let data speak for itself. So with that, for example, if someone does not believe in climate change, let's assume, now if the and that person is a data scientist, you will come across all sorts of people. So, but if that person himself does not believe in data science, in not in data science, of course, does not believe in climate change, and but when that person looks at the data and the data speaks for itself that yes, Earth is warming up, the level of oceans that is rising, so that data scientist should keep his or her beliefs aside. Let data speak for itself. If you are favoring a government, and if the party that is in government, you are favoring that party, you are uh, that party is your favorite. But still, if the data shows that after that party came into power, now the unemployment is increasing, and the economic condition that is deteriorating, let data speak for itself. So this is basically data first means that you keep your intuitions aside. You let data speak for itself, and based on the insights, based on the patterns that are emerging for it, we take decisions. Decisions are made based on the data. Now, uh, it also means that we recognize data. Now, data is becoming so important that it is a strategic asset, because data has information. Data has information that we can use for decision making, and this with this comes the continuous improvement that is needed. It means that we should be in a situation where we are looking to improve our processes based on the data that we have. Now, what are the benefits of it? We will talk about the risk as well. Now, the key benefits are, first of all, the decision making is accelerated. It's not only accelerated, it can also be real time. If, for example, when I'm so today there are different events that are happening. Tariffs is a big news, and it's supposed to be that way for the foreseeable future. Now, what is the effect of those tariffs? Again, keeping our political bias aside, they are good or bad, or you look at a country, see the data that is emerging from it, and that allows the decision maker to take the right step. So if tariffs are imposed, so decision makers should be listening at the data, looking at that, what is the short-term implication of that? What is the long-term implication of that? Does the theory that there may be a short-term shift in the markets and then the long-term gain, does that hold true or not? Or are we going towards that or not? So all of that is part of, if there is a disease, there is measles is basically, there's a breakout of measles in North America. Now, the thing is that how that disease is spreading, are the measures that are taken, they are effective or not? And now it also allows us, no better time than today to take this example, that it allows us to give faster response to market changes. Market is changing. It's unpredictable right now. And now what we can do is that so accelerated decision making, it can help us optimize our financial decisions, or it can be decisions related to measures, safety precautions for a spread of disease, or it can be government that is trying to help its citizen, or there can be so many other reasons. Now, if you want to look into the enhance customer experience, now it means that there can be personalized interactions, can be services that can be provided, or all of this will result in a better customer retention, because your customers will be satisfied with your efforts. But if, for example, there's an issue that appears, if someone's so I'll give you an example. So recently I needed to replace one of the parts of my in my bed, and I needed to visit IKEA. IKEA is the Swedish firm. Now, IKEA is famous for the way they use the technology. It's one of the gold standard, and let's take that as an example. So they try their best to use AI, to use data engineering and other things. It's just an example. Of course, it doesn't mean that I'm not trying to sell IKEA. I'm just trying to give an example there, that how, as an organization, they use data to make, first of all, their product better and the customer experience better as well. So what happened was that I visited IKEA. The part was there, and but the part number that I had, the part that they had, the part number was the same. The number matched, but what was there was that the material was different. I had a wooden bed, and that was basically the metal one. It was an automated process. I just needed to pick the part, and they have click and check sort of counters. I picked the part, but when I realized that it was not the one that I needed, So what I did was that I just they had a small computer there, and from there you could chat. So in real time, I basically mentioned that this was not what I need. The part number is the same, but the material is still different. Now they fixed that in 5 minutes. And that was again because I had basically rented a pickup truck for carrying the part. Everything was there. Because there was some mix up, but they were able to fix that. I was really amazed the way they were able to basically trigger that supply chain, and from their warehouse it took about 7 minutes to fix this error. So now for me it was such a good experience. Now, this is basically the power of the data. So someone was listening to that chat and that chat resulted in a decision, correction of a mistake or correction of what needed to be done. And the result was, it was not only me. It means that they were revisiting. Hopefully, they were looking into the why that happened as well, and that will improve their processes as well. So that will result things like this, examples like this, they result in operational efficiency. So it means that the processes, when there is a data driven automation, so data is consumed, it's used in data driven decision making. And based on that, there's a feedback loop as well. If there's an error, so there are lessons that are learned due to those errors. So it means that the end result is that the errors, they are minimized, and it also allows organizations to experiment with new data product. So it means that if you are launching a new data product, if you have those listeners, those where you are listening to the opinions, the sentiments that are coming out of your customer base, and based on that, you can correct your errors if there are any. Now, if you look into the current market drivers and trends, now one question that comes with data-driven decision making is, what about the privacy laws? Because if you start using data that has PII, personable identifiable information, where you can track a person, there are always security risk with that. There are always privacy risks with that. And it means that the data we are using, it should be under a different compliance regulation, depending upon the domain, the vertical that we are under. If the vertical you are that you are using, it's health, then HIPAA is so you need to figure out that the um, particular domain that in which you are doing this data driven decision making, this is under what compliance level, and you adhere to those standards. Otherwise, what will happen is that in the long term, there may be implications. If your data gets for some for reasons behind beyond your control, if your infrastructure it gets compromised, then there will be implications. First of all, you will lose trust among the customers that you have. So it means that when you're using data, uh, before you even start thinking about it, first you locate that you are under what compliance level, what needs to be done, what information needs to be removed. In general, when we use data, so we don't use race, we don't use religion, and we try to avoid anything PII that can identify a person. So it means that the SIN number, the first name, the email, the phone number, and other things that can identify a person. We don't want to use that. And special, so this one, we try to remove that unless there is a reason for it. Usually there should not be for pattern analysis, for decision making. We are looking uh, into the aggregated patterns. Not at the individuals. So for AI in general, usually we are looking for aggregated patterns, how as a whole a community works. What works for a group of people, low income people, what sort of products basically appeal to them, high income people, what sort of products appeal to them, or people from a certain heritage. So if the heritage is Chinese, then there will be certain type of food that will appeal to them. If the heritage is Indian, then there will be other type of food that if you are opening um, uh, uh, a new restaurant, then you have to figure out that what is the neighborhood, or what sort of restaurant will be successful here. What is the taste of the people? The type of the restaurant you're opening. Does mainstream also, for example, I live in Ottawa, as I mentioned. So Ottawa is you will not believe it, but shawarma. If you eat shawarma, that is basically Lebanese Arab food. Ottawa is the city which it has the most number of shawarma shops in the world. You can Google and check it. So the largest number of shawarma shops are in Ottawa, because the mainstream population, they have adopted that taste. If we are in office meeting and we want to eat lunch, so the consensus is okay, let's go for shawarma. It's not only Lebanese people. It means that the mainstream has adopted that taste, and it's a big thing that Ottawa, the Arab population is only 3 to 4% in Ottawa, but it has the largest number of shawarma shops. So it means that now, if so now for if you are taking a decision to open a new restaurant, so you have to look at the data in its totality. That what are the patterns, what are the likes and dislikes, and based on that you can take a decision, right? So now, hi, it seems that there was a glitch here. Can you still hear me? Okay, it seems that okay now. Uh, so this is basically where you look into so when you are taking this data driven decision making, so what you also look into the what are the competitive pressures that are there, what other people are doing. Based on that, what you can do is that you can look at the market trends. You can see that what works, what does not work. It can be about market research of opening a new restaurant. You can be in a government where you are changing a policy to facilitate your citizens, or you can be a doctor where you are looking at the effectiveness of medicine, that whether this is effective or not, or you may be in a local government trying to control the spread of a disease. All these are the examples where you have, again, critical decision making, which can affect the lives of the people. And you want to make sure that you are learning from the data, what happened in the past, what works and what does not work. And unless and until there is a fundamental change in the ground situation, whatever has happened in the past should work in the future as well. So it should give you those predictions. Now, when you consume the data, now the data itself, it has volume, velocity, and in addition to volume, it also has what is the velocity of the data, how fast your data is changing. You also have the variety, what different types of data you have, and you also have veracity. Veracity means that how trustworthy, how trustworthy your data is, because veracity uh, is critical when you want to use it for data-driven decision making. Right? So this is where when you are using it for data-driven decision making, then in that case, the veracity of the data that becomes important, that how trustworthy the whole thing is. Now, let's look into some real world stories. So we call it as verticals. You know, these are three verticals that we have looked into: retail, healthcare, and manufacturing. Three important verticals where data-driven decision making has actually proven its worth, where it's making a difference. Let's start with number three, that is manufacturing. Now, especially the news around us these days, they talk about a lot about the supply chain, that the import taxes or tariffs as they are called, they affect a supply chain, you know. Now, supply chain optimization, that is make or break for many global organizations. So it means that the supply chain optimization has been done using the real-time data over the years. So when here in a large store in North America, so the supply chains are spread across the globe. So it means that when something needs to be manufactured over the years due to globalization, about 40 years of globalization has resulted in supply chains that are distributed across the globe. They don't understand any boundaries, the political boundaries. This acts as a huge machine. And the way it has been laid out for the last 40 years is that different countries, they have different specialization. You know, they are, for example, if you look into the supply chain, there are two or three countries that have specialized in stitching the clothes. Vietnam, or there are other countries there as well. Bangladesh is another example. Now they have specialized in that. So they are, you can think that in a machine, that is your specialized location for getting this done. You know. So there are countries that have specialized themselves for assembly. There are other countries, Now, in order to come up with a product, you want to look into those supply chains, that when the order should be placed, what is the estimated time, where that should be loaded, how they will be ported, what is the cost associated with that, what are the taxes along the way, what is the estimated price, including the profit. So all of that is and if the policies remain the same, then your data can predict that. If the policy change, then of course you have to count that in. But in manufacturing, supply chain is a big thing. Now, supply chain is one thing, but let's zoom into those factories. I mentioned I'm in Ottawa, not too far away from here, 2 hours away from here. There's Bombardier. Bombardier, if you had heard about that, it is now bought by Airbus, but there is a manufacturing plant. When I was doing PhD, we visited that. So they are extensively using data for predictive maintenance. If for a part, so the idea is that in aerospace, we cannot afford a part to fail, of course, So we do a couple of things to make sure that we have almost 100% reliability for the parts that are used in aerospace. So we keep things redundant. So they are something, if something fails, then there is a redundant part, and we extensively do predictive maintenance. We do not want a part to fail. For example, in your car, because you're on the ground, you change your brake system if your brake when it starts to fail. But in aerospace, we don't do that. In aerospace, what we do is that before we err on the side of caution. If an engine part still have uh, more than 50% of life left, we just change it. So and there's predictive maintenance that will allow us to take those decisions. Predict and for aerospace, you can see that they are critical decisions, and for other products as well, the machinery within manufacturing, the products that they are making. Predictive maintenance is it makes sure that those expensive machines, they are because there is a lot of cost if the machinery is down. Then in healthcare, the patient outcome. So if there's a patient, there's a in North America, there is a data that is collected, that is readmission. If a patient is discharged from a hospital and that patient needed to be readmitted in next 10 days, something went wrong. It was a bad decision by the hospital. It was bad for the economics, both for the hospital and for the patient. It's bad for the health of the patient. Someone did not take the right decision. The patient was discharged from the hospital, and in the next 10 days, that person had to be readmitted. It's not that that person revisited. Visits are outdoor visits are something else. But if that person had to be readmitted again in intensive care, it means that something went wrong. This is a data point that is collected. It will, if we analyze that, it will improve the processes of the hospital. Now it goes a long way in improving the healthcare system and improving the processes. Then it can also be used to come up with the diagnosis. And the best example would be that in John Hopkins, they are using it for two things. One is basically the breast cancer. In breast cancer, if the breast is high density, in high density breast, it's difficult to differentiate between malignant tissue and a normal tissue. This is again, doctors, they understand better. I taught a course there, so I have some knowledge of it, but again, it's not my expertise. But for high density tissue, it becomes difficult, and machine learning comes to help there. So again, to differentiate between malignant and benign cancer, this is again very critical. The patterns that emerge out of it, John Hopkins have, if you have a lot of research on it, and they're also experimenting with looking at the brain scans, the healthy brain scans, and the malignant or not malignant. Let me take my words back. So if there's an onset of Parkinson disease, or there is in that case, the brain scan are this they have certain markers, as they call it. So now they are using machine learning or they are experimenting with using machine learning to differentiate between healthy brain and the one that have shown the onset of Parkinson disease. Now, it all is coming from the data. And the data we will learn that what is the marker for the onset of Parkinson disease. And then the retail is there as well. I already talked about the restaurant example. I'll not go in detail again. I also talked about the IKEA. So now these are the three verticals where it is proven that data-driven decision making does make a big difference. And if we talk about the risks there, for the privacy of the data, of course, you will see that the privacy of the data is critical here. So if you look into this one, this is where the privacy of the data comes to the critical level. Here, the privacy of the data is important, but it's not critical, I would say, but it's important. In manufacturing, this is data about the machines and the processes. So the privacy of the data, that is not relevant. It doesn't mean data is not important, but it may be important if It's about the preventive maintenance, the life time, or the failure rate of engine parts. Maybe if it's Boeing, and Boeing is looking into what Airbus is doing, may be important, but it's not to the degree in which the other two verticals that is important. Now, when you look at the organizations, we look at their data maturity model. That uh, the organizations, what they need to do is that as they are enabling data-driven decision making, they should evolve. They should evolve their architecture, where the way they are storing the data. So now, in a way, when we talk about an organization, their IT infrastructure, it has two dimensions. One is the compute dimension, how they are computing things, and one is the data dimension, how they are storing the data. Now, this data we are talking about, and this data is right here. So what we are talking about here is that now these are the different ways that you can store your data. First comes that if you are not paying any attention, your data will be stored in different silos, different isolated partitions. IT is not aware that what data is available in financials, and financial is not aware that what HR data is available, and HR is not or is not aware of any external customer data. Then what we have is that so this is the first one. Then what you do is that you organize it. If organized means that we create some sort of a data catalog. What is a data catalog? Data catalog is the database of metadata. Metadata makes data explainable, discoverable, and the database of metadata is a data catalog. So it means that if you have data catalog, if you have implemented that, it means that now it can be discovered that what type of data is across your organization. So now this is the second level. The third one is that now it is analytics driven. It means that it becomes fuel for generating insights. Now, data driven means, analytical means that you are looking into data. So we call it as business intelligence. You are looking at historic data, and you are not trying to predict anything. You are just looking at historic data. You are looking at that what are the insights coming out of it. So this was the promotion that you launched, and it resulted in 20% increase in sales. So it worked. This was the you spend $100,000 on this ad, and it resulted in increase in sales of 10,000. So it was a money that is gone wasted. You spend much more than what was the increase in sales. So, but this is all analytics driven. It means that this is the business intelligence. Then comes basically automated and AI powered. This is where you actually use the data to its fullest potential. That is the maturity level 4. Now what you're doing is that you're using it to come up with data driven decision making. Now, if you look into the uh, each maturity level, 4 of them. So when you are at the lowest level, of course, there is limited data sharing, and the reporting, because when you are generating reports, you are not aware that what type of data is available. So you're relying on manual or ad hoc reporting. When it's organized, now it means that there is a data lake, there is a data warehouse, there is a data catalog that makes all of them discoverable. But now they talk to each other. These silos, they are not in different silos. Now it's organized. That's why we have chosen to draw that like this. Now all the data points there, you see that what is available. Now this is the second level. The third level is analytical driven, as I mentioned. Now, it's more BI than predictive, but still we are making use of the insights that are coming off the data that we have. And the fourth one is now we are using it to its fullest potential. It's automated, it's AI powered. We are we are training our models. Based on that, we are predicting what will be our sales for next month. We are predicting how many customers will be there so that we can do capacity planning. We have used AI to optimize the layout of our stores. When you go to a big store, so they have a certain layout that appeals to the customers. There's a lot of machine learning that is used. The similar items will always be together with few exceptions. So that should be at the front. So lot of data that is analyzed to see that what works and what does not work, and what will be the price point of all of these. So now, if you look into the challenges. Now, the challenges at different maturity levels. So four of them. So let me uh, write it here. One, two, three, fourth. And the fourth one is our golden standard. So now let's look into the same thing here. What are the challenges at lower maturity level? So I will call these ones 1 and 2, especially the lower maturity level. So first of all, there is data duplication. So it means that there are multiple uh, sources of truth, because there are different data that is we never got a chance to consolidate that. So it was never consolidated. So there may be conflicting information coming out of it. It will lead to confusion, and eventually, if the data-driven decision making, garbage in, garbage out. So it means that if the data is garbage, the decision making will be garbage as well. And that will result in the mistrust of data. The management will think that no, this was not the right approach, because the decisions that were based on the data that we used, they resulted in loss of revenue, for example. There's a lack of governance. I said that ideally we want to have the database of metadata. Each table should have a metadata, a very short file that explains it. And if we store that in a database, that is essentially the data catalog. So in lower maturity level, there's lack of governance, because there is no clear ownership who owns the data. Then there is minimal cross-team collaboration, because we have not figured out the processes that needs to be there for data governance, for collaboration, for looking at so the truth, the information that is in the data. There's a term we use for it in machine learning, and the term that we use is called the ground truth. So this data is expected to have the best information of a physical phenomenon. You're looking at let's say that in Canada, there's a concern that polar bears, that is on the northern part, northern Ontario, and if you look into northwestern territories, they are they're under threat. So they are different IoT devices. They are very remote areas. There's a whole ecosystem that is under threat. They don't get fish. Because they don't get fish, there are other things there. There climate change there as well. They are fighting for their survival. because my passion is photography. I'm so this and I've traveled there and I've taken photographs of them. This is something that is close to my heart. Now, the decision making that the government is doing right here in Ottawa, the city where I live, it depends on the IoT devices that are placed there that gets the temperature, the motion detectors that monitor them, and that captures the data. For the data scientists, they crunch that data and comes up with the policies that hopefully can at least help them in the short term. Long term, we don't know what's going to happen because at least that part is warming up. There is a clear evidence that and you know the their habitat that is melting. But the the decisions that will be made here hundreds of kilometers away from where the physical phenomenon is happening, that is our ground truth. So the temperatures, their moving patterns, the fish that is available for them, all of them should be represented in complete accuracy. We don't know that whether this is accurate or not, but that is our as a data scientist, I cannot actually go there. It's almost impossible to go there, especially in winters, you know. So the ground truth is the information that is available in the data, and the data collection process, it should be done in a way that the ground truth is the ultimate truth, that is the actual truth, right? But what we can do here at our end is that at least make sure that this ground truth, our best shot as at a real phenomenon, we conform to when we create those policies, when we do analytics, when we do data-driven decision making. So we at least make sure that we first of all we are aware of that ground truth, we utilize that, we draw insights from that ground truth. And when we are manipulating the data, when we are processing the data, when we are creating those group by statements, so ground truth that is still respected. So now let's look into the core enablers to data maturity. So what is data maturity? Data maturity is our effort that we will like an organization to move from left to right, from 1 to 2 and 2 to 3 and 3 to 4. That is actually our maturity as we are moving up in the hierarchy. So it means that we want enablers, or we can enable this movement. We want to make sure that we are making progress from we are traveling from left to right. We keep going. So we need to have the strong data governance framework. We need to have uh, it means that the governance framework that we have, it should have the clear policies, data catalogs, lineage should be there so that if something goes wrong, we can backtrack and see that how the so as I mentioned that the ground truth should be there as we are processing. We do not lose sight of the ground truth, you know. So lineage is one of the ways that we make sure that we have that explainability. If we are processing the data, we can still basically have that traceability to see that where it's coming from. And then we are aware of the infrastructure and the tools that are available. We use data lake, data warehouse, and I already talked about the importance of elastic infrastructure, and elastic infrastructure, they result in scalable cloud-based solutions. And we hire the people who know what they are doing, you know, so it means that and there's a culture of learning. I already talked about this. And uh, then there is a space, there's time and budget for resource allocation, and failures. If we attempt at experimentation, people will take risk, they will experiment something. If the management can accept failures. Not everything, not every effort will succeed. So there will be around 10%, 15% of the efforts that will just fail. There's a team, they tried something for a couple of months and it just failed. It did not work out the way. So the management should be aware of that we are in experimental mode. And if you expect everything to succeed, then people will play too safe. They will not take any risk, and they will not innovate. They will just go by something that is already proven. So it means that they will not end up creating something new. If you want innovation to be there in your organization, then the leadership should be accepting that risk of failure as well. So I think it's time for a break. Let's take a short break, and then we will come back. Okay, enjoy your break.
Sure, we are now going to take a 5-minute break, but before we do that, we are going to launch a quick poll that we want to invite you to participate in. Doing so helps us know how we can better serve you by telling us who might be interested in more information or in taking some additional training. In addition, we have a lot more informative webinars coming up, so please go to netcomlearning.com/webinars in order to register.
Welcome back, everyone. Let's continue from where we left off.
Now, if you look into the um, from silo to smart, so it means that so when so it's difficult to get out of the comfort zone. If an organization is there for in its silo mode for 20 years, so it will take effort. It will take deliberate, conscious effort so that they can transform. They can move from lowest majority level to the highest. They start basically, first of all, the first step is creation of data lake and the creation of data catalog that allows discovery within the data lake. So it means that when we are enabling data-driven decision making, so the end result would be this should be the KPI. So what is the criteria of success? You know, so of course, from this to this, they will be they from when they are trying to move away from silo infrastructure. So there will be money that needed to be invested. There will be time that needed to be invested. What is the KPI? How we make sure that it's a success? So the KPI need to be defined. For example, this is a KPI that we're looking for 20% reduction in operational cost. There will be a time, there will be 6 months, there will be 8 months where this cost will be recovered. You will through better decision making, there will be other invisible benefits. For example, the increase in trust across the broader community that will be achieved. Management needs to zoom out and see that what was the overall benefits that were achieved, and there should be quantifiable KPIs is right in the start. And then there will be other invisible, if silo resulted in frustration, now you have a more efficient workforce that they know where the information is, and they are more efficient, they are more performant. Everything resulted in infrastructure that are conforms to performance excellence. Let's talk about what is cloud native. Now, cloud native is that now cloud is a big piece of the puzzle. It's if you look into the now cloud native means that the solutions that you are creating, they are they you do not basically create an on-premise solution, then you move to the cloud. This is not the optimal way of doing that. Cloud native are all the services that are offered in the cloud, and you design according to those services. Example of that would be that for example, in Google Cloud, there is a very popular tool that is called BigQuery. BigQuery, I teach for Google and teach for AWS as well. BigQuery is a data warehouse from a browser. And in my point of view, in my experience, I'm about to make a big statement here. BigQuery is the most powerful execution engine in the world. It's a big statement, right? You can use it from the browser. It means that all you need is a browser, and all you need is a SQL, the knowledge of SQL. Everyone has a browser, and everyone in this domain has some knowledge of SQL. So it means that anyone can use BigQuery. You don't need to worry about anything, but it's a cloud native. You had to commit. There is no equivalent of BigQuery on premise. It's a tool that is created for the cloud age. So you have to architect, you have to design according to the latest and greatest that is available in the cloud. So now, so the components of cloud data platform are that you have to think it through from end-to-end architecture. What is your data ingestion, where the data is coming in, and where it will be stored, data lake or data warehouse. Data lake is basically the data repository where that is created for analytics and for machine learning. So there's a difference between data lake and data warehouse. And the analogy that I give is that if you look into an actual lake, or in Canada, there are 20,000 lakes. It's the country of lakes. So let's take an example of an actual lake. Not too far away from where I live, there's a lake that is called Pink Lake, one of the most beautiful lakes in the area. There are different streams that flow into that lake. There's water there, of course, in the lake. The lake is so deep that it is yet to be determined that what is the depth. It doesn't mean that it cannot be if it doesn't need to be determined, but it's so deep that at the bottom of the lake there is no oxygen. There are details about the Pink Lake. But coming back to this, because this is just an analogy, a lake itself, there's water in the lake, but you cannot drink that water directly. It needs to be processed and then you can drink it. So data lake, this one is like that actual lake. Data is there, but you need to process it before you can utilize that. Data warehouse in its typical form is that process, bottled water. If you have a bottled water that is ready to be consumed, it is cleaned, it is ready for you to drink. So this is basically that processed bottled water. And usually data warehouse, because data is processed, it is part of your operations because data is there. So you can just consume that. But data lake is where you all those streams as add the water to that lake, and then we process and use it for analytical purposes. So the structured data, unstructured data, multimedia, all of that, we pile this up in a repository that we call data lake, and we use it for analytical purposes. But this is not ready to be consumed. It need to be processed before you can use that. But the processed data that is ready to be consumed is the data warehouse. But when you are moving towards different level of maturity, you need to have data ingestion process, you need to have data lake, you need to have different components of analytical services like the tools. I already talked about the BigQuery, but in Azure there are other tools available. Then you need to have different ML frameworks so that you can utilize, train the model and use it. And once done, you need to achieve the long-term success. It's not that you created a model and it's a done deal. It will be used for years to come. In that case, you need to have processes and procedures for governance, security, monitoring to make sure that things are they remain in good shape, and they enable high quality data driven decision making that is better than the alternative. So there are different options. You will see that there are different patterns. We need to be aware of those patterns, and we use that depending on so there will be what type of architecture are you using a serverless architecture. The cloud native components, usually they are serverless. So the cloud will be responsible for managing the most important component of your architecture, that is the server. And are you enabling the automatic scaling or not? What type of data do you have? And all of this will be important when you now the core steps to implementation. Let's try to think of a recipe. So first of all, you need to start with the business objectives. So you need to come up with both the functional and non-functional requirements. What is your metrics? What is the outcome? What you're looking for? You can look at the strategic goals that are there. So this is the first thing. So this is all what part, what needs to be done. What are the requirements? And then afterward, the how you do that follows that. So for that, you need to have enabled the data discovery. You want to make sure that you are aware of the platforms and the tools that are used. Then you are enabled for the long-term success. You know that what is the governance. I talked about the data lake. This is one of the powerful ways you can enable the governance. And then you learn from your first implementation. You go back and you see that how you can. So in this field, we would like to start with the pilot project. Pilot project is the solution of the problem scaled down to about 20%. So it means that this is the project that tests all the critical touch points, all the critical components. It tests your architecture, but it does not solve the complete problem. It just validates your architecture. It confirms that the assumptions that you are making, it works. The drivers that you are using, for example, you want to connect to Netezza. Now do the driver in place whether it works or not. Your the libraries that you're using, they work. There is no conflict in the libraries. The scalability that you are assuming, the cost that will give you a projection of the actual cost that is there, the time that it takes, it will give you it becomes a barometer of guessing what is the eventual complexity of your architecture. All of this is so you need to think it through, that what is the 20% scaled down version of your actual problem, and that is basically the pilot. And the pilot, from pilot you iterate, and then from there you scale. And what you do is that you incorporate the feedback and you refine you are in a constant mode of learning and refining your architecture. Now the practical tips that are there. So start simple, do not overcomplicate. So MVP is now there's a difference between MVP and pilot project. Sometimes people think that they are the same. MVP is something that you can give a demo that seems to solve the problem, right? So pilot project can be 20% scale down problem can be one of the pilot project deliverable, can be to generate MVP, or MVP can be different. Maybe pilot project will not end up generating the MVP. It will take one more iteration before you can come up with MVP, right? So in some use cases, it's not 20%. You have to it's 40% before you can actually demo something, right? Uh, so MVP is it needs to be defined that whether MVP is the deliverable of the pilot project, or you still need to iterate a couple of times before you go 100%. So you can generate the MVP. It should be clearly defined. And now over engineering is always a risk. So we should avoid over engineering, especially initially. There is no room for making things unnecessarily overcomplicated, right? And automate wherever possible. Wherever possible, don't hold back. So automation comes with so in the first time when you do automation, it will take more time because you are thinking about the design of the automation. It's compromising for the short-term gain in the hope for long-term success. Automation is always work that way. So whatever you do, you need to do, and you need to repeat over and over again. That is a candidate for automation. And invest in skill development is number 3, because if you do not invest in skill development, give time, space, funds for that skill development, so the people they don't have skills. They will learn on the job. It's like training a bus driver on the job. There will be accidents, and that will result in much more wastage of the time and wastage of the money as well. So it's when because it's a new field, so invest in the skill development. There is not a single recipe how you do that, but upskilling the team is important. And then you monitor, optimize, keep learning. This is not a done deal. Even if the solution is perfect, it looks perfect. Things will change. The assumptions on which your solution is based, they may change. The physical phenomenon will shift. The requirements will change, and there may be newer solutions in the market. You need to be aware. You need to monitor. Then what you do is that you need to identify that what of the use cases they result in the most so what is the low hanging fruit? Identify those high value AI use cases, and based on that, you start with quick wins, but you also keep in eye that what is the long term. Start with quick wins. It will, especially for the stakeholders, it will show that you are going in the right direction. But you also keep them informed that long-term projects, it will take time, effort, and there will be errors on the way as we are aiming for the perfection. So that risk should be well communicated. Now, if you look into the data prep, now this is an era where data-driven decision making, we are talking about data-driven decision making, but data needs to be prepared. So I talked about basically this example about the data lake and data warehouse. So data is usually in data lake right here. So before we prepare it and make it convert it into bottled water, you filter it. So it needs to go through the preparation process. So it needs to go through cleaning, deduplication, missing values, that is called data imputation as well. Biases needs to be removed, and other things need to be corrected as well. All of that will result in cleaning of the data. And in my analogy, we are talking about bottled water. Now, it means that, and when we are trying to extract the value out of data, uh, for that, we need domain expertise. So when we talk about different verticals, we talked about these three verticals. Now, in 2025, as we are looking at the market and the needs for data scientists, we are looking for people who are master and they have expertise of our domain, of a vertical. Now we are looking at the market. There's a demand for data scientists who have expertise in healthcare. Market is for people who go deeper in a domain. They become expert of their domain. That is why basically this expertise in domain, that becomes important. So we are looking for this domain expertise right here. So with domain expertise, it brings insights that how data should be prepared. So an example would be that in visa processing, if the visa has been refused in the last 6 months and nothing has changed, that person has applied again. It's a straightforward case for refusal. Nothing has changed. It has already been refused. Person applies again, and that's a straightforward case for refusal. So the insight. So if now if I'm a domain expert, I need to do and I don't need, I need to look at those three fields. It's a straightforward case for refusal. So only the domain expertise, knowing the business, the other so many things that knowing better about the domain will bring to the data prep, resulting in much better data-driven decision making. And there are different tools that are available, that Airflow and data flow, that can help you orchestrate your processing pipelines. Now, this is a GCP architecture. If you talk about Google Cloud, Google Cloud, there are lots of tools that are available. I talked a lot about data catalog. In Google Cloud, we have a tool that is actually called data catalog. What is data catalog? I define that as the database of metadata. It means that all the data that you have, it should have the metadata, and the database of metadata is here. If someone wants to see, for example, wants to see the data about HR data, so that person can look at the metadata, and that will point it. Okay, HR data is in cloud storage, or the HR data is in PubSub. Now, uh, let's talk a bit more about the components that are on the left hand side. So data catalog is it allows you to achieve the second level of maturity. That is where you have broken down those silos, and now the data is discoverable, and everyone is able to first of all be aware what is available and can make use of it. I talked about BigQuery. Now, BigQuery is a data warehouse on a browser, and you only need to use or only need to know SQL language to use it. So it means that anyone can use it from anywhere. That is basically BigQuery. And I teach for Google and AWS. So in my point of view, in my experience, this is the most powerful execution engine in the world. It's very powerful. It is very elastic. It can provision 20,000 nodes in 2 seconds if it is needed. If you are looking for if you have 5 billion data points, you want to process them, you write a query, it will sense that it's a heavy lifting. It will provision 2,000 nodes only for 30 seconds. And the cost is you have to pay 2-3 cents, but you don't have to wait hours for it. BigQuery is a game changer. It's the most powerful tool in the cloud space that is there, and it's the most popular tool that is in Google Cloud Universe. All paths lead to BigQuery. This is always when I teach, I always say that BigQuery is one of the cornerstone for Google Cloud architecture. And when we're talking about any database solution, when you are talking about that, when you're talking about large scale database, BigQuery shines. Then we have PubSub. PubSub is used when you have high velocity data. When you call an Uber and you see that car moving on your cell phone, Uber is Uber. I have taught for Boeing and Uber and HSBC. Uber is one of the, or Shopify. So all of these companies, Walmart included, all of them uses Google Cloud. This is the common thing among all the companies that I mentioned. Uber is a big consumer of Google Cloud. It's now when you see that that car is moving as you have ordered the food, it's coming towards your home. You are feeling hungry, and you are just monitoring that. This is the PubSub that allows that real-time data that is streamed to your cell phone, and in real time you can see that now it has reached your neighborhood, and now you are just looking forward to it. Now PubSub allows the data to be streamed from point A to point B in real time. Now then there's cloud storage, the perhaps the Swiss Army knife that, but cloud storage is also our enabler for data lake. When we talk about data lake, the diagram that I drew, how you are going to realize this data lake? You will realize this data lake through cloud storage. Cloud storage is where you can store the data in any form. You can create a bucket. In that bucket, you can add structured data, unstructured data, multimedia data. So this is your how you realize, how you implement a data lake in Google Cloud. So now when we talk about, we said that in the fourth level of maturity, you are now using machine learning. And here, what you need to do is that you need to you need to train the model. And for that, you need to choose the algorithm. And once you have chosen the algorithm, you need to fine tune it. And if it's for data driven decision making, the explainability is important. Ethics are important. You need to make sure that you are not victimizing the vulnerable community. This is important. And as a data scientist, there are sensitive issues around race and religion. But when you are enabling data-driven decision making, if there's a bias in the data against a religion, against a race, then that bias, first of all, you need to be aware of that. And when you're enabling these data-driven decision making, we need to monitor that because historic data may have those biases. It may have those wrong assumptions about a race. It may have, and if we are not careful, then those biases will trickle down to the solutions that we are creating. And as the decision makers, they start relying on those tools that we have created. So the biases will be carried forward to the decisions that are made using those tools. Of course, the results that are not what we are hoping for. And there are tools, fortunately, like that will allow you to monitor. Lime and CHAP is two of them. So you can look at the explainability at the point level or at the aggregated level. Point level means that each decision you can trace back. If someone's visa is rejected, you can, if someone says, okay, my visa was rejected due to my race and religion, can government go back and defend that no, this was not due to your race and religion. This was basically because you overstayed. When you were given the visa last time, you overstayed. The decision was related to that. So that explainability is needed. Or it can be at the aggregated level that across basically our community, whether a certain race, their income is low, for example. What are the reasons for it? Is it due to or any corrective measures that can be taken? Anything that government can facilitate to make sure that they come at par with the other communities? So this is where we make sure that we use data science for the good of the humanity, not to victimize in anything anyway. And we should be careful, extremely careful, as we start using data for data-driven decision making. Now, when we are deploying solutions, so I said that only 20% of the solutions, they are actually used in production. It's a very small number, unfortunately. But if the some of the reasons I already talked about, but if you are if your model is successful, if your solution is successful, you need to basically deploy and use it. And the methodologies around that, they are inspired from the principles of DevOps. It means that because we are looking for the iterative process, that continuous learning, the continuous improvement of the model, it means that it's not one time that you give the solution from the dev, the solution goes to ops and we are done. So there is a constant feedback loop that the solution is operationalized and then it needs to be optimized, operationalized again, optimized again, operationalized. So this feedback loop in machine learning, we call it as ML ops. ML is the dev portion, ops is the operational portion. So it is enabled through different principles. We containerize it so that the dev and ops, there is no dependency, so the living environment remains unchanged in the dev and ops. Otherwise, we don't want to go into those issues related to libraries or conflicts. We just containerize it. It's the recommended thing that we do. Then we do performance monitoring. If there is drift that is detected, we want to make sure that if things have changed on the ground, those changes are reflected in the solutions that we are offering. We retain the schedules, and we are doing governance, and we are at the compliance level. I talked about this based on our vertical. We need to figure this out, that we are under what compliance, what regulations, and based on that, we may need to enable the audit trails, version controls of the model, depending upon what are the requirements. Real-time examples are that in manufacturing, there can be predictive maintenance. We already talked about this. So for e-commerce, let's look into the recommendation engines. You have a product, you want to connect to the users, and the recommendation engines will match the demand to the supply. So if there's a demand and there's a supply, recommendation engines are those matchmakers, and you can use them. And fraud detection is for banking, so it may be less than 0.1%, but it's a big loss to the bank. So if we can come up with based on the data, the examples of the data, if we can see that, okay, if someone is using credit card this far away from the home for a large purchase, and so these are the patterns, then it's basically fraud. All those are so that should be blocked, and these are all the use of the data for data driven decision making. So we are talking about cloud native ingestion or processing. So wherever there's a choice, we should be, first of all, aware of the solutions that are available in the cloud. Go for cloud native because they are elastic solutions, they are scalable solutions. Use analytics and BI platform. BI, we talk about BI when you look at the historic data to look at insights. There is no predictive component in BI. Then predictive component is here when we start using ML framework. AutoML is the term that we use in Google Cloud. We use AutoML when it's a push button solution. You want to create a model just by the push of the button, where usually domain expertise is not needed. So that is on a lighter note, this is basically replacing a data scientist with a machine. Again, it's a lighter note. There are limitations of that as well, but AutoML is here. And then we want to make sure that there is end-to-end integrated solutions that are there. Talk about data governance. Now, data governance is not. It may need more than one tools. It may need more than one services. So data governance, there is not a single solution for it. How you achieve that? So if you look into that, so you need to turn on the lineage. You need to turn on data cataloging, and then you want to make sure that for both for compliance and for governance, you need to make sure that you have the right access controls. There's encryption, there's role-based access. You are following the principle of uh, least privilege, and you have encryption available at rest and in transit. And based on the vertical you are working on, so there will be different regulations that you need to respect. HIPAA, PCI, uh, uh, GDPR is more general, as we know, and and we also need to keep an eye that how the policy may change. It's a evolving area. We need to keep an eye that how the new regulations comes in. Now, for example, these days there's a regulations that are trying to uh, trying to cater for fake news, fake information. Now, these are new regulations that are coming, they're emerging and they are changing. If you are in that domain, if you have that component, then you need to keep an eye, because the regulations, they are yet to be solidified. They are emerging, they are changing. Now, now, if you are building a data-driven culture, what it means is that it starts with bringing the leadership on board, explaining that why this is important. Become a champion for data initiative. And then you need to share, you need to remove those silos. Everyone should feel that they have benefit in that. Then comes the data literacy and training. Of course, if the knowledge is not there, how they are going to use it, and incentive always help. Acknowledge the employees who use data effectively, and that will help us creating the culture of data driven decision making. And now the now as I mentioned, that if the organization is in its current mode for the last 20 years, it will take effort. They will be in their own comfort zone. So they are first of all, it should be explained that what is the benefit, and the complexity should be managed. So through the pilot project, through MVPs, through uh, through uh, uh, through first of all, creating those KPIs in incremental manner. So and so give demos, involve stakeholders early, and so then incremental wins, make sure that they are celebrated. And the fears about the risk and the misconceptions, they may have read an article that this does not work. You need to address that fear, instead of just dismissing that. So the best practice, we are looking at ongoing enablement. So for that, there should be continuous education. There should be cross-functional collaboration. Then now this is something that I recommend. So in a team of 20, there should be 2 or 3 people. They should have a center of excellence. It means that they are best equipped, they are best trained for this domain. Not everyone may have ability to learn it to the deepest level, right? So you should have the center of excellence within the team that for guidance, for guidelines, for problem solving, they are responsible for taking that detailed decisions about the architecture of your organization. It benefits everyone. So this is so and the team where I work, we have a center of excellence, and it has really worked well. So hopefully everyone will come to the same level, but picking up people who are for the center of who opt for the center of excellence to become the center of excellence, it will give a jump start. Then there will be cross-functional collaboration. It's not that the BAs and from BA to data scientists and data engineers, everyone should be involved. There should be a continuous education plan for it, and then there should be community of practice. It means that the grassroots collaboration. There should be forums for sharing success and, more importantly, failures. So this is, again, I'm repeating over and over again. So whenever you are doing innovation, not everything will succeed. Some of the so everyone should be comfortable in sharing their failures. That should not show up in their performance reviews. So that culture is discouraged. It is not an enabler for innovation that is needed for creating these new solutions. And now, if you look into the key takeaways, so data first is a strategic initiative. And now then there is maturity level. We defined 4 maturity levels. Now it's a good idea that first of all you say you are closest to which maturity level. Maybe you already in number 2. Then number 2 is where you have a data catalog. You have removed those silos. In that case, you need to see that how you can bring BI and eventually AI to go to the next levels. So cloud native, wherever possible, we talked about using the cloud native over the alternative solutions on premise that are brought to the cloud, virtualized. So cloud native is always better. And the other ones we call is at lift and shift, because what we do is that we already have something working. For example, you have MySQL working on your on-premise. Now you move to the cloud, and now it becomes Cloud SQL. It's still MySQL. It's a virtualized version of that. You have chosen not to use a cloud native component, and it means that you may not be using the full power of the cloud because the elasticity is limited. You still need to babysit your SQL database for applying the patches and making sure it's stable. So you're not taking full advantage of the cloud. And the governance and the culture shift, we already talked about this. Now, the actionable items are that, first of all, conduct a data maturity assessment, see that whether you are in 1, 2, 3, or 4. Then you look into the low hanging fruit, So because management, stakeholders, your team as well, they need to be aware, they need to have a sense that you're moving in the right directions, And then you plan a phase. So the plan is important, that with KPIs, that how you're going to quantify the success, And finally, this is important. You have that culture of continuous learning, And now this brings us towards the end of this webinar. And any questions?
Thank you, Imran. That was very informative. Now, I know everyone's looking forward to the Q&A session, so go ahead and start putting your questions into the questions panel. And while you do that, I'd like to give the presentation rights over to Ifla, our product marketing person, who's going to introduce you to some of our fantastic promotions and webinar-related courses.
Thank you, Tracy. Insightful session. I believe everyone must have learned something new today or would have been able to brush up their skills around Google Cloud technology.
So firstly, I'm excited to announce that Netcom Learning is now an authorized training partner for Google Cloud, making us your go-to destination for cloud skilling. With this milestone, we are proud to offer comprehensive training across the three leading cloud technologies globally: Microsoft Azure, AWS Cloud, and now Google Cloud. So we, Netcom Learning, is your one-stop shop for cloud skilling. I would also quickly like to take you through some of our hand picked resources, which we think will immensely help in accelerating your Google Cloud skilling journey. Well, this document here that I'm presenting has been shared with you all in the handout section of GoToWebinar panel. You can download this document and access all the resources and browse all the offerings we have curated for you. So first up is the list of our recommended courses, which we feel will best suit your learning journey after attending our masterclass. So all these courses here are hyperlinked. Feel free to go through them post-event and check out the course descriptions and prerequisites and the value it can add to you and your team skill sets. Additionally, we have curated a blend of resources, including our upcoming and on-demand events, as well as some informative and educational blogs. So you can make the most of these resources to gain extensive knowledge on the Google Cloud topics they cover. Also, here I would like to inform you that today's masterclass session is being recorded. So, in case you want to refer back to any of the topics that were covered by the trainer today, we'll be sharing the recording link with you through emails, and also you can access the link here on the handout so that you can revisit the session and learn at your own pace. Now, apart from our virtual sessions, you can also catch all the relevant updates related to IT and business training on our social media handles. So please feel free to follow us on LinkedIn, Twitter, and Instagram, and also subscribe to our YouTube channel for all the latest updates. Our official pages and channels are linked here on the icons. Finally, if you have any suggestions regarding the topics you would like us to cover in our upcoming webinars and masterclasses, please don't hesitate to send us a direct message or leave a comment on our social media posts, or you can just simply email us at google@netcomlearning.com. We would definitely try to come up with the sessions